This is a talk about rich programmed activity models. Perhaps not the final name for this particular technique, but it's an introduction to a technique to support with problem structuring that is part of the action research work that I'm doing. And this is a talk that was given at the Systems Thinking Systems Practice Conference at Hull in March 2026. So, for some context first, my name is Karthik Suresh and I am a consultant. And I primarily work with clients on energy and sustainability projects. So, you're probably aware that energy and sustainability has been a complex and changing space for a while, and clients and different participants, different stakeholders have had to figure out how they are going to operate within that space. Just some years back in 2017-18, I had the idea of maybe trying to use SSM as a way to work with clients to engage with this space that was full of problematic issues. Everything from how do you collect and use energy data to how do you figure out a decarbonisation plan. And this became the foundation for a piece of, for a program ongoing action research, where I started with using SSM and leaned into the practice while working with clients on decarbonisation. Now, so far, what I've talked about is the process of inquiry. So if you have clients who have a problematic situation, so for example, if you were to work with me, what I'd do is invite you to an online call, a Teams call or a Zoom call. And during that call, we'd talk through your situation and I'd take notes. Now these notes are kind of rich visual notes on an infinite canvas. At first I thought that what I was doing was rich picturing from SSM, but the form and nature of the notes started to differ from what is traditionally seen as an SSM rich picture. So to capture this distinction, we started to call them rich notes, and there's quite a lot of information out there already. Now these rich notes are an initial discussion, and from that discussion you tend to range across a series of topics, and those topics emerge as problematic areas. So that's the work so far. If you're interested in that and you search for my name and for rich notes or look on YouTube, you'll find a few videos where we discuss what rich notes are so far, and we're still working on getting a paper out that describes that technique. But the real question is, what next? So you've met with your stakeholders, you've had a conversation, you've talked about the situation, you've taken some notes, and from that there is a bit of an understanding has emerged. So what do you do with that? Now again, it might be helpful to see what these look like in real life. So this is what a set of rich notes looks like after a conversation. The main thing about them that differs from, say, rich picturing is about structuring the situation, while these notes grow as we talk through the situation, and we identify that they grow in a rhizomatic way. They branch and they essentially spread out in all directions. And within those notes, there is a bricolage of techniques used to capture different kinds of information. So again, all this is in the rich notes section. But once you've had the conversation, you find these areas potentially you talk about. So for example, some are clearly, we spoke about these particular topics in these areas, and we might need to talk about some things that are missing. So for example, leadership in this conversation might have been missing. Or the input from leadership was missing, so we just have placeholder to remind us to bring that in. So what do you do with this? Well, if you do the background away, it looks a bit like there is a model here. There are a set of elements, and there may be some relationship between them. So how do you work with this? Well, if you do SSM and you follow activity modeling through the Czech-Landian procedures, there are a few prerequisites. So first of all, in that situation, you need to figure out what kind of transformation you want. What is changing into something else, and you try and capture the essence of that transformation in a root definition. Once you have those elements, then you can start to figure out which activities will help you achieve the transformation that is described by the root definition, and then you rearrange those activities till they make sense, and you end up with a complete activity model. But the thing to remember is that this activity model is linked to a root definition, and it's a logical set of activities that will help you achieve something. Now, in my practice, I wasn't really doing this. The way in which I came up with the model elements was different from this way of thinking about transformation and working your way through it and creating an activity model. And obviously, from Checkland's point of view, you can have multiple activity models, because it all depends on the root definition, which is based on the perspective you take. Now, as a programmer, I was looking at activity models and saw them primarily as graphs. So a graph is a description of a thing that has nodes and links. So you put the nodes and links together and you end up with graphs. And graphs are very similar. They are essentially activity models, conceptual models, the soda diagrams you see, all those are nodes and links. So they're different representations of graphs. So it made sense to me to use graph drawing software as a way to represent graphs. Now you have online software that allows you to do this kind of thing, but my preference is to use open source wherever possible. So GraphViz, or Graph Visualization, is an open source command line program that's been around for a number of years that I've used previously. So I quite like the idea of using GraphViz as a way to draw graphs. So how do you actually create a model using GraphViz? Well, you write some code. So it looks a bit like this. You end up with a, you define your nodes, you define the connections between them, you wrap it all up in some stuff that describes the graph itself, and then you click a button and it turns into something that looks a bit like this. So you have a transformation from a coded model into a visual model. It seems fairly small, but the difference is you aren't hand drawing boxes and arrows, and you aren't in the PowerPoint moving them around trying to connect arrows. It is one representation in code, and then it gets transformed into a finished model. Now again, as a programmer, I want to do the least amount of effort and I don't want to repeat myself. So just looking at the previous coded model, there was a lot of repetition. And it really came down to what are the most important things? Well, they are a description of the nodes and the links. So if we look at this particular model, if we're trying to see that and convert it into an actual model, not with the same word, but you essentially process it, you look through and think, how do I represent this as a model? I thought, well, I could just do it using a text file. Each line is a node in the model, so you just kind of write your way down and list out your nodes, and use line number to refer to them. And then you add a little separator like dot links that says, I've now finished writing my elements, and then you write down the connections between the nodes using the line numbers as a reference. So this is quite quick and easy to do for small models that are 8 to 10 lines. And again, you go from that initial model to a visual representation, and you can go backwards and forwards. So the advantage of this approach is it's fast and it's easy to modify. So you don't need to mess with the actual image itself. You just go back and change the code, and you can reorder the lines, change the numbers, and just work between the two till you're done. And I have used this quite a lot in my own practice, where after we have a discussion, if I want to summarize the discussion, I create a model, because that allows me to take maybe 90 minutes of discussion and represent it in a way that I know I can come back to this and go, yeah, that's what we talked about, and this is how the elements are connected. Okay, so what does it mean? And why is it important or different or relevant, or what sort of contribution does it make? Well, first of all, within SSM, there is a process that has been described around using SSM. So you enter with a situation that somebody considers problematic. They look at the sort of transformation they want and think up a root definition. They then create an activity model, the Chetland called HOLOMS, to represent the activities that are required to enable that transition, and then use that logical model as a source of questions to help with a debate about the situation. So if your model says, well, we need to do these 3 things, and you say, well, do these things exist in the situation? If not, maybe we need to bring them in. So the models are essentially an input into this discussion. In my own practice, I enter into a situation where there are a number of other stakeholders, typically, because as a consultant. And I put a frame around that situation and talk about it. So as we talk through it and describe the situation from the point of view of the people that are involved, you see these areas of these issues emerging, and so you know that there are a bunch of things you want to talk about. And then from that, I create a model. So the model itself now can act as a substrate. You can put the model down and go, well, we talked about the overall issues that came up with these, the overall situation that came out with these sets of issues. We've modeled those issues, and now we can talk about these in more detail. And perhaps, 3 of them don't require any more because the things that happened in the past, or the things that we just need to be aware of, or things that are well controlled. But perhaps there's a place we need more input, and a particular area we should focus on next. So now what you can do is take action to improve the situation, or you can talk about how to improve the situation. it means that you're able to say, well, here's an area, let's discuss that in more detail, and that builds up its own potentially sort of rich notes around that topic. And you go through these learning cycles, so you talk, model, talk, etc. Now, if you compare the whole ones, so is this just SSM? Am I just using SSM as as it should be, or am I doing something a bit different? So that's one of the things about SSM being a methodology, and here I am trying to apply SSM, but it may be that some of the things I'm doing are slightly different, and those need to be called out. So within so if you compare holons and programmatic models, holons are a source of questions, and I usually use program models as a summary of the situation. Now, they can be an input into the next discussion, so they could also be a source of questions, so it's not completely clear-cut. Holons are constructed as a logical representation from a root definition. Now again, Chetland in some of his later work said it's not necessarily exactly as connected. A root definition may indicate direction of travel, and the conceptual model may indicate what you need to do, but they don't need to be very tightly coupled. However, in much of the literature, it is really that the activity model is a logical representation that is tied to the root definition. While the program models are a bottom-up set of steps, set of elements. They're not necessarily perfect, they're not exhaustive, but they capture the things we talked about in our session. And holons are typically seen as an input to a debate, while program models are often an output to inform the next action we're going to do. So what's the contribution here? Well, one contribution is just about efficiency. You are going from handmade artifacts, so I include hand drawing models or hand making them in, say, PowerPoint, into more of a programmed approach. And again, there are tools that let you do this. It's about the nature of programming. But perhaps more relevant is you will see many examples of models where they're either quite small, so they're comprehensible, but then as you build them up, they get bigger very, very quickly. So you have these models with hundreds of nodes that are very difficult to actually understand. Now, people have addressed this through the notion of recursion, for example, in VSM, or hierarchy, or clustering. But I think if you take a programmer's mindset, you can be a bit more structured about it, because nobody writes, or very few people write, a 10,000 line program. What they'll do is build modules, and these modules will work by themselves. So the idea might be that you build activity models that are built in modules, and you may have high-level modules that describe the architecture of the whole system, so there is a hierarchy, and each of those have sub-modules, or your modules that work together in parallel. But just the idea of having a modular structure is interesting. So for example, you may have an initial module that has 5 nodes that describes everything you want to do, and then each of those is described in terms of the implementation of it with a set of other modules that also have a bunch of nodes each. Now, here's an example potentially of how you could break that up. This is a representation of something called the TCFD, the Task Force on Climate-Related Financial Disclosures. It's being superseded by IFRS, but they had 4 elements you need to work on: governance, risk management, strategy, and metrics and targets. And within those 4 pillars, there were a bunch of things you needed to do. And so you could break those into these individual models and say, well, there's a couple of items for governance, 3 items for risk management, and together all these different elements, if you work on them, will get you to where you need to be within the overall structure. So again, it's thinking about organizational change like a programmer. And how would you program the organization to change? Well, you'll write the program, and you'll write in a modular way so that you can run these parts separately, and then when they all run together, you get the change that you wanted. And the main reason you would think about things in terms of in a modular approach is that it's easy to think about it. You can keep those 5 or 6 things in your mind and then load the next bit and think about them. While we all see these images of hundreds of items, and it's very, very difficult to just start to understand what's going on and critically evaluate whether those models are going to operate in the way that they're expected to. Another consequence of this, which is interesting, is you can use AI to help you out. So once you have this programming language almost that I've created, this simple set of lines and connections, you can ask AI a question like, for example, talk about Toyota's approach to zero carbon manufacturing, and that might give you a series of items to think about along with the links. And so you end up with a model that is created by AI, but now this can be used as a basis for discussion. So again, it can describe something and you can critically start to think about this with a group, but you aren't going to have to create a whole bunch of stuff to start off with. You can go into a discussion with some information already created. So this could be an interesting way, again, about helping us get rid of some of the drudge work of building initial models, but create the time and the space required to have discussions and critically debate what is going on. Now, a lot of the ways that I do things is via is through code, but most people don't necessarily want to code. So I put a little vibe coded a little application on top of my scripts that I use to create this code, and I run that in a small Raspberry Pi. So you want to access that, here's the QR code. It may not always work because it is a small machine, and hopefully it doesn't get hammered by the internet. If you do have trouble or you are interested in this, then get in touch and we can talk about it a bit more. Okay, so in conclusion, I think graphs are a powerful way to bring a whole set of representations under one sort of approach. And if you use programs to create graphs, there are some efficiencies in being able to go from a program representation to seeing the visual output as a graph and then going backwards and forwards and refining these models till you're happy with them. And the models by themselves, they sit there and there are a bunch of nodes and connections. So how do you add richness? Where does the rich appreciation come into this? And it starts with you have a situation and you maybe something like rich notes, which I talk about elsewhere, to capture your first impressions. And then you summarize those insights into a model. You then use that model to discuss more about the situation, which then leads to more models. And in this way, through a combination of engaging with the situation, a process of inquiry, a process of modeling to help cement your understanding, and then improvement, you essentially learn your way into improving the situation that you're working on.